Alrighty, thanks, Lee. Yeah, the last talk that I'm going to do today really relates to what I did this morning. And this morning I was talking about measuring growth using the conventional ways that we normally can measure growth with body weight, withers height, and body condition score. One of the things we're really interested in, though, is the growing skeleton. Height is a good indication of skeletal growth, but there are some other techniques that we can use that are relatively non-invasive that give us a better idea of how the skeleton grows. So I'm going to share a little bit of that information with you today. First of all, when we're talking about the skeleton, we need to divide bones into two broad categories: flat bones and long bones. And flat bones are like the scapula, the mandible, and long bones are the femur, tibia, humerus, the ones that you would normally think of as bones in the limbs. They really are derived from two completely different types of development, and I'm going to talk today just about the growth of long bones. So this is a diagram that indicates the architecture of a long bone. You have the shaft here, the diaphysis. You have the epiphysis down here, articular cartilage on the bottom, and you have a growth plate. Long bones elongate from the center, eventually completely ossifying except for the articular cartilage. When we look at long bones of the skeleton, the way they grow is first they create cartilage, and then they convert that cartilage to bone. So cartilage cells first grows and produces a collagen matrix, then that gets mineralized later and gets converted to bone. This is I borrowed this diagram from Wayne McElraith's, one of Wayne's papers, showing the ossification of a developing bone. When foals are in utero, there is no mineral in the skeleton. It's all cartilage. The primary center of ossification is in the cartilage that's in the shaft of the bone. As the bone grows, that ossifies. There's a secondary center of ossification in the epiphysis, and eventually that bone is going to become completely ossified with the exception of articular cartilage. And as the bone grows, let me go back one, as the bone grows, there remains a growth plate here, the metaphyseal growth plate, and that's where the bone can actually elongate from. And these growth plates close at different times depending on what bone you're talking about. Basically, as a general rule, the further the growth plate is from the center of the body, the sooner the growth plate closes. So the short pastern closes before the long pastern, cannon bones, the knees, and on up the leg, with some of the bones not closing actually until quite a while later. I mean, the pelvis, even some of the growth plates up at 3 and 4 years. But when the growth plates are closed, it's done. The bone can no longer grow any longer at that point. If we go back and look at this that I showed you this morning, it's pretty amazing to me that 50% of that total height gain occurs in the first 4 months of a foal's age. So these long bones are growing like crazy. They're elongating at that point in time. So what will eventually happen, though, is as all of this ossifies, you'll be left with this growth plate where the bone continues to grow, and you'll have this articular cartilage. That's the cartilage that's between the bones, between the joints, that gives it a frictionless surface to go across. And it's at this growth plate and the articular cartilage where you get developmental orthopedic disease. So DOD is a disease that occurs in these two locations. And DOD, developmental orthopedic disease, is sort of an umbrella term that's used to describe a group of diseases that affect the skeleton of growing horses. But they include physitis, or it's called epiphysitis. Actually, that's anatomically not the correct term. Just physitis, that's an inflammation of that growth plate that's left. Wobblers, the cervical vertebra type, again with deformities in terms of how this cartilage is converted to bone. And the ones we're really worried about, osteochondrosis and OCD, those are defects of the articular cartilage. They're not necessarily defects of the long bone. OCD can occur if the bone that is underneath the articular cartilage has a problem in that epiphyseal bone, but these are problems that occur at the end of the bone in joints. And there's a lot of things that can cause DOD. There's certainly a high genetic predisposition to certain types of DOD. Certain breeds have a higher incidence of DOD. We're interested certainly in the effect of nutrition on DOD, environment and trauma, because if there's trauma to the bone, to the joint, and blood can't deliver to the joint, then you can create one of these problems. Nutritionally, if you look at what causes DOD, you can really heap that into three different problems. And I'm not going to spend a lot of time talking about the nutritional effects of DOD. In fact, I'm not going to talk much more about DOD at all. I'm going to talk about the rest of the bone here in just a second. But just briefly, if you look at what can cause DOD, nutritionally, it's going to be deficiencies of something, excesses of something, or imbalances of something. Polly already talked this morning about the imbalances, that the ratio of calcium to phosphorus, zinc to copper is very important. Frank, deficiencies can cause some problems, and excesses, particularly of energy leading to excess growth, can create some problems as well. But I'm going to spend some more time today talking about the actual mineralization of the bone. It's usually something we don't talk very much about in young growing horses. We usually just talk about DOD. As the bone develops and you have this mineralization going on, the bone is mineralized with this crystal that's a combination of calcium and phosphorus. These crystallize around a collagen matrix, and the bone becomes stiffer and the bone becomes stronger. And this cartoon shows basically what happens. The other thing I think that's sort of hard to get your head around is that the bone is continually remodeling. We normally think of a skeleton like you would see a skeleton standing up in a classroom or out in white bones out in a field. But in fact, this is living tissue, and it's continually turning over, continually turns over. In order for bone to grow, it has to remodel. And the way it remodels is there are cells called osteoclasts that dissolve old bone and cells called osteoblasts that form new bones. And so it's this turnover that causes bone to be remodeled and renewed. The osteoclasts, they're the cells that break down bone. They use acids and enzymes that dissolve the bone itself, the calcium and the collagen from the old bone. That calcium gets released into the bloodstream. Then it can be carried around to different parts of the body and be reused. And so there's a lot of turnover. The osteoblasts are the cells that build bones. They produce collagen, and you can look at collagen like rebar, the reinforcing rods that we use in concrete. That's collagen. They also produce a protein glue called osteocalcin. Osteocalcin coats the collagen, and it attracts the mineral to stick to the collagen, and that forms a hard bone. So really, if you look at bone changing, you've got a balance between bone formation and bone breakdown. If there's more formation than breakdown, the bone grows. If that's exactly equal, then the bone's in equilibrium. And if bone breakdown exceeds formation, you have demineralization of bone. So those are the three things that can actually happen. And I told you that this is the skeleton is metabolically active, but some of these stats I'm sure are going to surprise you. Number one, calcium in bone turns over 100% in a foal in a year. So all of the calcium in the foal's bone is completely turned over within a year. In adult horses, calcium in the bone turns over 18% in a year. So what you see is there's massive blood flow to the bone, there's constant remodeling, and in a foal, all of the calcium in the skeleton gets dissolved, released to the blood, and remodels, and that allows growth to occur. If we look at birth, a horse only has about 17% of its mature bone mineral content at birth. I told you earlier it's 65% of its mature height, but it only has 17% of bone mineral content. Maximum bone content's probably not achieved until the horse gets to 6 years old, long after thoroughbreds have been retired. At 6 months, a horse has got about 69% of its total bone mineral content. At a year, it has 76. So from birth to a year, it goes from 17% to 76% of its bone mineral content. So the skeleton's growing like mad, there's massive turnover, and there's a lot of mineralization. We've used a technique that helps us understand bone mineralization and bone growth. And it's a real simple procedure, actually. You take an x-ray of the foal's cannon bone and you expose next to the cannon bone, and Roger, I'm going to stick with you, an aluminum step wedge. And what this is, it's a chunk of aluminum. That's how you spell it, really, is aluminum, if you check. That has different thicknesses. And so what you do is you expose it next to the cannon bone, and you can express the density of the bone relative to the thickness of the metal. The other thing, so if that's how you take the x-ray, this is a cross-section of the bone, so if you cut it in half and you're looking at the top, basically what this does is it measures in aluminum equivalents the relative density in 3 different areas, in a lateral side, a medial side, and the medullary side. The hole in the middle of the bone is the medullary cavity. This also allows us to measure the width of the bone. So there's software where you take these x-rays, you can measure the density in these different areas, and you can also measure how wide these different parts of the bone are. So this would be an indication of a bone growing over time. This is what we would see if we took these x-rays repeatedly, that first we've got at 106 days, as the foal grows, the bone gets wider and denser also. So we can make these measurements over and over. The nice thing is it's relatively inexpensive to do, and it's non-invasive. You're not hacking the bone up. There have been studies that have related the density of the bone in these aluminum equivalents to actual bone mineral content. There were extensive work that was done at the University of Florida where they took cadaver bones and they did hack them up and measure the actual amount of bone mineral, and they related it to these aluminum equivalents, and they got a good equation to predict bone mineral content from these x-rays. So we've used this technique in 3 different studies that I'd like to tell you about. First of all, we wanted to just see what happens to bone in normal foals that are grown on a Kentucky farm. In this particular study, we followed 30 thoroughbred foals that were raised on a commercial farm. Monthly, we took these x-rays, they were weighed, the regular measurements were also made. This graph I showed you this morning, this is average daily gain in a typical bunch of foals. The black line here is bone mineral content. So you can see that bone mineral content starts quite slow, increases quite rapidly. It was interesting in this group, we got a drop in bone mineral content in the autumn and winter, and then in the spring, the bone mineral content increased, so it stayed about on track with where you would have thought it would have been before. These are the widths that we saw, and this sort of surprised me. It may be obvious to you, but again, we measured the width of the medullary cavity, that's the middle of the bone where the bone marrow stays, and then we measured the lateral cortex, the outside of the bone, the medial cortex, the inside of the bone, and we're expressing them here in millimeters of width. Look at the medullary cavity. It doesn't change over time. The size of the hole in the bone doesn't change. It stays exactly the same. What changes is the width of the lateral and the medial cortex. And if I express that as a percent change, you can see, again, the medullary width doesn't change at all, but we get big increases in the lateral and the medial cortex. So the bones rapidly grow and it's turning over, the osteoclast are breaking it down, osteoblasts are building it back up. This is bone mineral content, so using that regression equation to calculate the total amount of mineral in the bone against total bone width, which is in purple here. So bone width is in millimeters. Bone mineral content, the way this is expressed is if you took a 2 centimeter slice of a cannon bone and you measure the mineral in that. That's what the bone mineral content is. And again, if you look at this in terms of percent increase, you see there's a really big increase in bone mineral content. So you're at 150% increase from when the foals are born. So there's a lot of bone mineral content that's occurring during this early time. And look at the bone mineral content that occurs just in the spring and summer when essentially the the foals are still on mares. So this bone mineral content occurred from milk, essentially. If the horse is fed a well-balanced diet, then the largest single factor that's going to affect bone remodeling is exercise. And that's what I'd like to spend the rest of the talk talking about, is what effect does exercise have on bone remodeling in young horses. So remodeling, again, it's a response to exercise, and it involves removing bone cells with the osteoclast and then building new ones with the osteoblast. So one theory of bone remodeling is that the osteoclasts, those cells that break down bone, they recognize a change in the mechanical properties of the bone. It signals that, hey, there's a strain here, there's a stress here. The osteoclasts wake up and say, we need to strengthen that part of the bone. And there's this is called Wolff's Law. You may have heard of Wolff's Law. It's that remodeling is the effect of strain. So getting enough strain to signal an increase in bone development while not overstraining the bone is the real trick in terms of trying to build a stronger bone. So again, trying to make it where you can get bone formation when the foal is growing, or equilibrium when the skeleton's an adult, and prevent demineralization is what we're trying to do when we have different types of exercise for foals. There's been several studies that have looked at the effect of housing and exercise on foals and what it did to bone mineral content. This was a study that was done in the Netherlands, and they took foals from birth to 5 months, and they either housed them in box stalls, raised them on pasture all the time, or a third group, they raised them in box stalls, but then they sprint trained them. They actually gave them sprints each day. And what they found was that the ones that were housed in box stalls and not given any kind of exercise had 37% less bone density than the ones that were on pasture or that were sprint trained that were housed in box stalls. These authors, though, caution against the sprint training, that might not be the best idea with 5-month-old foals because of some possible negative long-term effects. Michigan State's done some really interesting studies in this area as well. And this one, they took 17 Arabian foals, divided them into 3 groups, a 56-day study. One of the groups, they kept in stalls 24 hours a day. One of the groups, they kept on pasture half the day, in stalls half the day. And the other one, they kept on pasture 24 hours a day. They standardized their nutrient intakes. And what they found was the foals that were kept on pasture either 12 or 24 hours a day had increased bone mineral content. They had increased cannon bone circumference, which is another way of measuring bone width. And their take-home message was, keep foals, weanlings, and yearlings turned out at least 12 hours a day in order to stimulate, to give the sort of strains that are necessary to increase bone remodeling and bone growth. And then finally, there was another study that was done in New Zealand where they took 2 sets of 6 horses. They kept these guys out on pasture all the time for 18 months. And one of the groups, though, they did 1,000-meter gallops 5 days per week. And this was starting from when they were only 3 weeks old. They started to do this training with these foals. And they said the ones that were exercised had fewer gross lesions in the joints, greater bone fraction at the end of the cannon bone, and higher bone formation rate compared to the non-exercised. However, they cautioned that the thickness of the articular cartilage was less in those horses that were the foals that were actually given forced exercise. So again, I think this illustrates that exercise is important for bone, but it's better if you let the foal do it on their own. We did a couple of other experiments to look at the effect of changing housing, and in this case, you know, as you have yearlings, they're sold and then they go off to be broken in for training, there's some pretty big changes that occur in terms of their overall housing. So we had the opportunity to follow a group of foals during this process and look at the changes in bone mineral. So in this particular experiment, we followed again a group of 30 thoroughbred yearlings that were entering race training. And the way this particular group of yearlings were treated is that they entered training in late November on a central Kentucky farm where they were turned out most of the time. During that time, which I'm labeling as day 0, they were only in stalls for 6 hours per day. So in other words, they were out 18 hours a day. During that 6 hours per day, they just took them out and they jogged them in a paddock. So that's what they were doing when they started this training thing. In December, they moved the horses to a training center in central Kentucky, which was probably the first mistake, because December in central Kentucky, and as Roger mentioned, January and February can be really bad. There wasn't very much turnout available. They stayed at this training center the rest of the year. Now, in most instances, those foals would have gone to Florida or South Carolina where it's warmer, where they could have gotten on with things. This particular year, January and February, happened to be really bad again. And because of that, they were only lightly exercised in an indoor arena because of the bad weather. They weren't able to get stuck into proper training. They were kept in this sort of environment through the rest of the experiment. In March, the weather got better, so they increased their training intensity and got up to the training intensity you would expect of a 2-year-old as you're breaking them in and getting them ready to go. So we've got 3 different phases to this. One where they were back at the farm, kept out most of the time. One where they got put in stalls and didn't get a lot of exercise, and one where they were put into intense training. This shows bone mineral content in those 2-year-olds. You can see the green part was when They had been at the farm. This is where they got confined. And for those 2 months during confinement, where they put them up, but they weren't able to exercise them very much, you see a drop in bone mineral content. When they began to train them heavily again, you saw a return in bone mineral content. Bone width actually dropped quite a bit. You got a return here. I don't know what happened there, because if you look at medial cortical width, which is the inside of the bone, you can see, again, you got a drop in the width of that bone when they were confined. When they began heavy training, that bone width returned. And then finally, this is osteocalcin. That's that bone glue I was talking about. That's what's made by osteoblasts to make the minerals stick to the collagen. When there's rapid bone turnover and bone formation, you see an increase in osteocalcin, and you can measure that increase in the blood. And you see here what happened. You got a decrease in osteocalcin during confinement. When they started to train them, it went back up. So this shows that restriction of free exercise with just light work can have a negative effect on bone properties. When they got on with proper work, they ended up to remineralize as you had hoped. There was some work that was done at Texas A&M before this, where they did exactly the same experiment with racing quarter horses. What they found there was that exact drop. When they took them out of being out in a paddock all the time and put them into training, they got a drop. But what was interesting about their study is they measured injury rate as they started to go into heavy training, and they found a relationship between the amount that they demineralized and their injury rate. So trying to prevent those bones from demineralizing before they go into heavy training, or if they come back from rehabilitation, is something that we should consider. So we wanted to know, before this just shows what happens in a racehorse when it trains. This is an untrained racehorse. I've been talking about the lateral and the medial cortex. The front of the bone is the dorsal cortex, which we can't measure with these x-rays because we're measuring from straight on. But what you see when a horse trains, the bone remodels and it thickens that part of the bone to make it stronger, because that's where the strain actually occurs. We were interested if there was anything that we could do nutritionally to try to prevent some of this drop in bone mineral that we got when we changed different types of environment. So we did a study following up from the study of the 2-year-olds, where we devised a nutritional product that we thought could help minimize bone demineralization. We took 12 thoroughbreds, 8 of them were 2-year-olds, and 4 of them were 6-year-olds, and we used them in a 5-month, 3-phase study. During the first month of the study, phase A, the horses were turned out daily in a paddock for 5 to 6 hours, but they weren't forced to exercise. So the rest of the time they lived in their paddocks, in their stalls. They just got turned out for 5 or 6 hours a day. Phase B, we put the horses in training on our high-speed treadmill. And I'll show you the training here in a bit, but it got up to where it was pretty good training. Then phase C, the last month, we put them in stalls and didn't give them any exercise. We confined them the way that you would confine a horse after surgery. You'd confine a horse after a bow, that sort of thing. No exercise really at all. We blocked them by age and randomly assigned them to the treatment groups. The only difference between the groups is one of the groups got 120 grams a day of this supplement. Throughout the rest of the study, they were weighed and condition scored, and we adjusted their grain so we could maintain their body weight. The product that we used, we made a combination of nutrients, minerals, and vitamins that we knew were important for bone growth and remodeling. But what we did is we combined this with a special protein source. And this is a whey protein derived protein source that has some real unique properties in terms of affecting the osteoblast and the osteoclast. They have there's part of this protein that increases the number of osteoblastic cells, the cells that produce bone and that stimulate osteoblastic collagen production. Those are the shafts that are needed to be mineralized. And it does this by upregulating a specific gene that increases collagen formation. It also suppresses bone destruction by the osteoclast by inhibiting one of those enzymes that helps to dissolve the bone. So we combine those together. Again, the first 28 days of the study, the horses were in stalls all but 5 to 6 hours when they were in paddocks. And this is what happened to bone mineral content. So we were able to get an increase in bone mineral content over that 28-day period when the horses were only exercised on their own for 5 to 6 hours. So we were pretty happy about that. We put the horses in training, and again, they were 3 days a week on a treadmill, 3 days on a mechanical walker, and we started with walk, trot, walk, and built up to walk, trot, canter over the 12-week period. When we introduced this exercise to the horses, the effect went away. The mechanical strain on the bone was apparently enough that it was able to maintain bone mineral in equilibrium so that the amount of production and breakdown were the same. In the last phase, we locked them up. We locked them up for 28 days without exercise. And this is something that a lot of orthopedic surgeons, when you have joint surgery, it's lock them up for 28 days or 30 days. So we were interested to see what happened there. And with that, we were happy to see that in the confined horses that were given this supplement, we were able to maintain bone mineral content, and we lost bone mineral content in the ones that were the control group that was demineralized. So we think that this, and this shows the overall study. So this is bone mineral content. We got an increase here during turnout that went away during exercise, but it maintained bone when they were completely confined. So we think that there's probably an application for this in situations where you can't exercise a horse. It's because you've got them locked up for whatever reason. What we would prefer is that you continue to exercise the horse and let the strains regulate how bone is mineralized, but in situations where you can't, this may have some application. So what have we learned from here? This is probably something that you all knew. Foals need exercise to mineralize bone. The more you can keep foals outside and let them in groups where they can exercise against each other, where they can run, that they can cause the strain to get the bone to turn over and remineralize. Pasture turnout's really the best form of exercise. That's in all of these studies, in every single study, the horses that are kept out on pasture do as well as any other treatment group. If you have to use forced exercise, do it with caution. Forced exercise, when they do it in these studies, they pick sort of randomly what they're going to do, and some of them are pretty extreme. Forced exercise can be on a mechanical walker, and that is some exercise, which is better than none. But again, pasture turnout is probably the best way to go. And then if you have to put a horse up and you can't take it out, it looks like the nutrients that we put in Duraplex seem to help in terms of preventing the demineralization process. So I'll stop at that. Right on time, I think. Thank you very much.